Hi everyone. In this video I'm going to teach you how to compute the area of a triangle using trigonometry. For those of you who watched how to compute the area of a triangle using analytic geometry, I think you'll agree this way is a lot easier. So here we have our typical right angle triangle, and we want to compute its area. And of course the formula that we're going to use in this case is the one that we know and love so well, which is area equals base times height divided by 2. Okay, so in other words, we need to know what the base is, we need to know what this length is here, and we also need to know what the height is, so in other words, this length here. But of course, from our previous lesson, we know that this side, if we call this our angle, theta, this side is the adjacent side, and over here we have the opposite side. Okay, so for a right angle triangle, it's actually pretty straightforward. We just need to compute the length of the adjacent side and the opposite side, and we're home free, because we'll just multiply them and divide by 2. I guess just as a numerical example, the only thing I'm missing in this case is I'm missing an angle, and I'm missing the length of my hypotenuse, which I need in order to get these other guys. So how about I just do that? I'm going to choose a hypotenuse of 10, and I'm going to choose an angle of, I don't know, what does that look like? 20 degrees? 30 degrees? Let's go 20 degrees. Okay, so then, with my hypotenuse set at 10 and my angle set at 20, then I can compute my different sides. So I won't go through the full step using, or the full rationale using the reference triangle, but the adjacent side has to be 10 multiplied by cosine 20 degrees, and the opposite side is going to equal 10 multiplied by the sine of 20 degrees. Okay? Pachow. So now that I have the length of the adjacent side and the length of the opposite side, I'm going to put those into my area formula. Actually, first I'm going to zoom out a little bit. Now I'm going to put them into my area formula. So area is going to equal base times height divided by 2. In this case, the base is 9.40. The height is 3.42. And don't forget that you have to divide that by 0. So I get, roughly speaking, 16.1 units squared. So there's my area, about 16.1 square units. Okay, not bad, right? Well, time for the next one. Here's my second example, and you can see in this case that I'm given the length of the hypotenuse, and I'm given the length of the base, but I don't have the height. All right, this side here is unknown. Oh wait, I shouldn't do that. I'll call it h for height. Okay, so how am I going to find the height in this case? Well, there are a couple options. For one thing, you can use, well, one easy way I suppose would be to use the Pythagorean theorem. You already have the hypotenuse and you have this leg over here. You can use the Pythagorean theorem to get the height. So that might be the most efficient way. So in this case you need to remember that h squared plus 5 squared equals 7 squared. So in other words, h squared equals 7 squared is 49 minus 25. So h squared equals 24. So h equals the square root of 24, which is about 5. Okay, a little less than 5. So now we have the value of h, and again we just need to go into our area formula, base times height divided by 2. the base is 5, the height is the square root of 24, and we divide all that by 2, and we get approximately 12.2 square units. Alright, so there you go. We didn't even have to use trigonometry in that case. We just needed to use the Pythagorean theorem. Okay, now we have an example where this is not a right angle. Right? There's no right angle specified on here, and I've tried to draw this one so that it doesn't even look like it has a right angle. And we need to, and again, the idea is still the same. We want to figure out the area of this triangle. Well, what I'm going to do is I'm actually going to show you how to do it in 2 ways. All right, let's say for the sake of argument that we're given an angle and a length. So the angle that we're given is this one, and we'll say that that's 25 degrees. And to make our life easy, let's just say that we're also given the base, which in this case, do I want to use the base? Let's see. Let's say we make this 10 units there. So that's our base, 10 units. In order to figure out the area of a triangle, you need one more piece of information. And in this case, I'm going to say we know this side here. And we'll say that's 8. Okay, so that's the information that I know. I have 2 side lengths and the angle that those sides form. Alright, there's no formula that we know yet that we can just put all these into. So I need to do one additional thing here. I need to figure out the height of my triangle. And in this case, because of the way it's drawn, I will say that my height, I'm going to use this as my height, so this altitude. And to figure out that height, you need to realize that what I've done now is I've drawn a right-angled triangle like this. And in that right-angled triangle, I know the hypotenuse, and I know our reference angle. So I can use that information to calculate the height of my triangle. Let me use a different color. So in this case, the height of my triangle, which I will call h, equals 8 sine 25 degrees, which is approximately, go back to my calculator here, 8 sine 25, that's approximately 3.38 units. Okay, with that worked out, now it's actually pretty straightforward. I can just compute the area from the usual area equals base times height divided by 2. My base is 10. My height is this 3.38. And then I divide that all by 2. And I get a number pretty close to 15. Well, sort of. It's 16.9 units squared. Okay, so is there a formula? Kind of. You're still using the same formula, area equals base times height over 2, but you have to go through that extra step of figuring out the height of your triangle. Once you realize that, you can basically put that idea into a different form to combine those 2 steps into one. So let me show you what I mean by that. We know that area equals base times height divided by 2. But if you look closely at where this height came from, you can see that the height is related to the angle and this side length here. So that side length I haven't given a name. In this case it doesn't, it's 8, right? We know it's 8 units long, but you can basically write that as base times, I don't know, I'll call it B. No, that's base. That's unfortunate. I'll call it C instead. So if you think of this as length C, so it's C sine, now I have to give the angle a name. And normally we use theta, but in this case I'm going to use the letter A. So I have C sine A all over 2. And again, this is kind of unfortunate because I have an A here and an A here, and they're really not the same thing. So that's a bit tricky. But nonetheless, this is how the equation is usually formed, and it's often written in a way that's a little more, a little bit compact in that you write 1/2 BC sine A. So what does that all mean? It basically means if you want to calculate the area of a triangle, as long as you have 2 side lengths and the angle that they form, so in this case B is my base, right? 10. B is my base. C is this other side here, 8, right? And the angle that they form, that's the 25 degrees. If you have this bit, and this bit, then you can put all of that into your formula and work out the area all in one go. So I'm not really keen on people memorizing formulas, but this is one that sometimes can be a little bit more useful than the standard base times height divided by 2. So I offer it as a possibility. Okay, that's all for today, folks. Thanks very much for watching. Have a great day, and don't forget to be awesome.